Welcome to another deep dive. We're going to be tackling some pretty big questions about the universe today.
Oh, yeah?
Using Stephen Hawking and Leonard Mlodinow's book, The Grand Design, as our guide.
Okay.
We'll be trying to unpack their perspective on how humans have tried to make sense of the cosmos.
All right.
From ancient myths to the mind-blowing implications of M-theory.
So what's really fascinating is that Hawking and Mlodinow don't just present like a history of science.
Right.
They actually kind of weave it into this larger argument about the nature of reality and our place in it.
So let's start with something that might seem a bit out there.
Okay.
The Vikings believed that solar and lunar eclipses were caused by these two wolves,
Oh, wow.
Skull and Hadi, chasing the sun and moon.
Right.
And whenever a wolf caught its celestial prey,
Yeah.
bam, eclipse.
That's a wonderfully vivid image, isn't it?
Yeah.
But what's, I think, really crucial here
Yeah.
is that it demonstrates a fundamental human impulse, this need to explain the patterns we observe in nature.
Right.
Hawking and Mlodinow argue that this drive is at the heart of our quest for understanding,
Yeah.
whether it's through these ancient myths or through modern scientific theories.
It's interesting how those early attempts at explanation
Yeah.
often attributed natural phenomena to the actions of gods or supernatural forces.
Exactly.
Oh.
But then we see a shift in thinking with the Ionian philosophers in ancient Greece.
Mm-hmm.
They began to propose that nature wasn't ruled by like the whims of gods,
Okay.
but by consistent discoverable principles, what we now call laws of nature.
It's remarkable how these thinkers, without the tools and technology we have today,
Right.
were already laying the groundwork for a scientific understanding of the universe.
Yeah.
I mean, Thales is credited with predicting a solar eclipse way back in 585 BC.
That prediction might have been a lucky guess,
Yeah.
but his approach using observation and calculation to predict future events
Yeah.
was surprisingly similar to the scientific method we use today. And then there's Pythagoras, who
Mhm.
discovered the mathematical relationship between the length of a string and the musical harmony it produces.
Wow.
A very early example of theoretical physics.
So we see these early glimmers of scientific thinking
Yes.
emerging alongside those mythical explanations.
Right.
It makes you wonder, what would those ancient philosophers have thought
Yeah.
about modern physics and the concept of, say, M-theory?
That's an interesting question.
Yeah.
While their methods were limited, their core drive to seek natural explanations for the world around them
Right.
is the same drive that fuels scientific inquiry today.
I'm fascinated by how those early attempts at scientific thinking were both groundbreaking and limited.
Yeah.
They lacked a formal scientific method, but their legacy is undeniable.
Precisely.
Right.
Their insights laid the foundation for this concept of laws of nature,
Yeah.
which is a key theme that runs throughout the Grand Design.
Okay.
Hawking and Mlodinow pose some really fundamental questions about these laws that I think we've all pondered at some point.
All right.
What are they? Where did they come from? Are they truly unbreakable?
Those are questions that still spark debate and intrigue even today.
Absolutely.
When we talk about these laws,
Yes.
are we simply talking about patterns we observe,
Right.
or is there something deeper going on?
That's a great question.
Yeah.
Hawking and Mlodinow use the example of the statement, the sun always rises in the east.
Okay.
We might think of it as a law of nature,
Yeah.
but it's really just a generalization based on limited observation.
Oh.
A true law of nature goes beyond simple observation.
Right.
It provides a framework for predicting a wide range of phenomena.
So observing that the sun rises in the east every day isn't enough.
Right.
We need a deeper understanding of the mechanics of our solar system, the Earth's rotation, to truly grasp the underlying law that governs this phenomenon.
Precisely.
Okay.
And it's these underlying principles that Hawking and Mlodinow are trying to get at. They delve into those three key questions
Yeah.
about the nature of laws,
Oh.
their origin, whether there are any exceptions, what we might call miracles, and whether our set of laws is the only possible set,
Right.
or if other universes could exist with different rules governing them.
Those questions really highlight the tension that often exists between scientific and religious perspectives,
Absolutely.
especially the idea of miracles or exceptions to natural laws.
That's where things get really interesting.
Okay.
To explore that tension, we need to talk about Pierre-Simon Marquis de Laplace
Okay.
and his concept of scientific determinism.
Laplace, the man who claimed he could predict the entire universe if he had enough information. That's some serious confidence.
He was undoubtedly a bold thinker.
Yeah.
Laplace argued that a complete set of natural laws, combined with knowledge of the universe's state at any given moment, could theoretically predict the entire past and future.
Wow.
Leaving no room for chance. Miracles or divine intervention.
This idea of scientific determinism seems to directly challenge the notion of free will.
Yeah.
If everything is governed by unbreakable laws, do we really have the freedom to choose?
That's a question that philosophers have grappled with for centuries.
Right.
Descartes tried to reconcile these seemingly contradictory ideas by proposing that the human mind exists outside the realm of physical laws, allowing for free will.
So, a loophole for free will.
Yeah.
I like it, but I have a feeling modern neuroscience might offer a different perspective.
You're right.
Yeah.
Neuroscience suggests that our thoughts, choices, even our feelings, are ultimately products of physical processes in the brain.
So where does that leave us?
Right.
Are we really just puppets on a string?
Yeah.
Are actions predetermined by the laws of physics?
Hawking and Mlodinow don't offer like a definitive answer, but they encourage us to consider the implications of these scientific models and how they challenge our assumptions about free will and the nature of reality itself.
Speaking of challenging assumptions,
guys.
They introduce another mind-bending concept, model-dependent realism.
Okay.
Does this mean we're stepping into the Matrix?
It's not that far off.
Okay.
Model-dependent realism suggests that there might not be a single true reality, but rather different models that describe different aspects of the universe.
Okay.
Like in the Matrix, our perception of reality might be based on a constructed model.
Right.
A simulation, if you will.
So are we saying that everything we experience is just a figment of our imagination?
Not exactly.
Okay.
Model-dependent realism doesn't deny the existence of an external world.
Right.
What it proposes is that our understanding of that world is always filtered through the lens of the models we create.
I see.
Yeah.
So it's not about whether reality exists, but how we perceive and interpret it through the models we build.
Yeah.
It's like choosing the best map for navigating a specific terrain.
No single map can accurately represent the entire Earth's surface.
Right.
You need different maps for different purposes.
That's a great analogy.
Yeah.
And that's what Hawking and Mlodinow are getting at.
Okay.
There might not be a single theory that describes every aspect of the universe.
Which brings us to M theory, this network of theories.
Right.
That Hawking and Mlodinow believe might be the closest we have to a theory of everything.
Yes.
So how does M theory fit into this idea of needing different maps for different terrains?
Think of M theory as a collection of maps, each describing a specific range of the universe.
Okay.
These maps overlap just like maps of the Earth, and they agree in those areas of overlap.
Right.
Each theory within M theory is good at describing phenomena within a certain range, and they connect to one another in a consistent way.
So it's a bit like a jigsaw puzzle of theories.
Yeah.
Each piece providing a crucial part of the overall picture.
Precisely.
But what makes M theory so special?
Why do scientists think it might be the key to understanding the universe?
What's really fascinating about M theory is that it allows for different universes, each with its own set of apparent laws.
Wow.
It suggests that the extraspatial dimensions beyond the three we experience can be curled up in a multitude of ways. Each configuration leading to a different universe with different apparent laws.
Multiple universes.
Yeah.
That sounds like something straight out of science fiction.
It does sound like science fiction. But it is rooted in scientific theory. Though it pushes the boundaries of what we can currently observe and test.
Right.
The very idea that our universe might be just one of many is both humbling and awe-inspiring.
It completely changes our perspective on our place in the grand scheme of things.
Absolutely.
But if there are all these possible universes, how did we end up in this particular one?
Yeah.
What determined the laws that govern our reality?
That's one of the biggest mysteries that M theory tries to address. And it leads us into the next major theme of the grand design, the origin of the universe.
So we've gone from exploring how humans make sense of the universe to the mind-blowing possibility of multiple universes.
Yeah.
Where do we go from here?
Next, we'll delve into how our understanding of the universe's beginnings has evolved. From ancient creation myths to the scientific evidence for the Big Bang.
Sounds fascinating.
Yeah.
I'm ready to dive into the origins of it all.
Let's do it. Before we jump into the Big Bang,
it's
worth noting how drastically our view of the universe's origin has shifted.
Yeah.
We've gone from these stories of gods and mythical beings to a picture painted by scientific observation and mathematical models.
It's a pretty remarkable transition.
It is.
I mean, the Bushango people believe the world was vomited up by this giant god named Boomba.
Right.
It's a far cry from the Big Bang Theory.
It is. And what's interesting is that Hawking and Mlodinow don't dismiss these creation myths entirely. They see them as early attempts to grapple with those fundamental questions about existence, purpose, and our place in the cosmos.
So how did we move from those mythical explanations to the scientific model of the Big Bang?
Right.
What convinced scientists to embrace such a radical idea?
The evidence came from a number of sources.
Okay.
But the first clue was the observation that the universe is expanding.
Okay.
In the 1920s, Edwin Hubble discovered that distant galaxies are moving away from us. And the farther away they are, the faster they're receding.
So the universe isn't static, it's constantly growing.
Exactly.
Well,
and if we rewind this expansion, it suggests that everything must have originated from a single, incredibly hot and dense state.
Okay.
What we call the Big Bang.
That's a pretty mind-boggling concept to grasp.
It is.
The entire universe emerging from a single point.
It is. And initially, there was a lot of resistance to the Big Bang theory.
Really?
Some scientists were reluctant to abandon the idea of a static, unchanging universe.
You can't blame them for being skeptical.
Right.
It's hard to let go of long-held beliefs.
It's true.
Even when confronted with new evidence.
But over time, the evidence for the Big Bang became overwhelming.
Okay.
Not only did Hubble's observations of an expanding universe support the theory, but the discovery of the cosmic microwave background radiation, the faint afterglow of the Big Bang, solidified its place as the prevailing model of the universe's origin.
Okay, so the evidence for the Big Bang is pretty solid.
Yeah.
But how do we even begin to visualize this event?
Right.
It's hard to wrap our minds around the idea of the entire universe starting from a single point.
It is a challenge to visualize.
Yeah.
One helpful analogy is to imagine the universe as the surface of an expanding balloon.
Okay.
As the balloon inflates, the galaxies on its surface move farther apart.
Yeah.
Just like the galaxies in our universe are moving away from each other.
That's a great visual.
Yeah.
So it's not that the galaxies themselves are moving through space, it's that space itself is expanding.
Precisely.
Wow.
And this leads to a fascinating point that Hawking and Mlodinow emphasize.
Okay.
This expansion doesn't affect the size of objects held together by forces.
Okay.
So the size of an atom, for example, remains constant.
Yeah.
Even as the universe expands.
So the expansion is happening on a cosmic scale.
Right.
Not on the level of the building blocks of matter.
Exactly.
Okay.
But here's where things get even more interesting.
Right.
Hawking and Mlodinow suggest that this entire process, the Big Bang, the expansion, the formation of galaxies and stars and planets, it wasn't the result of some grand plan or divine intervention.
But wait, so they're saying it all happened by chance?
Not exactly by chance.
Okay.
They argue that it's a consequence of the laws of physics, particularly as described by M theory.
Right.
According to M theory, the universe can spontaneously create itself out of nothing.
Whoa, hold on.
Yeah.
Creation out of nothing.
I know, it's a big one.
That sounds more like magic than science.
I know it's hard to grasp.
Yeah.
But in the realm of quantum physics, the seemingly impossible becomes possible.
Okay.
The vacuum of space isn't truly empty.
Right.
It's filled with quantum fluctuations, particles and fields popping in and out of existence.
So even nothingness is more complex than we might think.
Exactly.
Okay.
And according to M theory, these quantum fluctuations can create tiny regions of space-time with enough energy to trigger a rapid expansion, a Big Bang.
So it's like the universe bootstrapped itself into existence.
Yeah.
Driven by the inherent energy and randomness of the quantum vacuum.
That's one way to put it.
Wow.
And it leads to an even more profound question that lies at the heart of the grand design.
Right.
Why does the universe exist at all?
Right.
Why is there something rather than nothing?
Now that's a question for the ages.
It is.
It makes you really ponder our place in the grand scheme of things.
Right.
If the universe can create itself out of nothing, does that mean our existence is simply a random fluke?
Right.
Or is there a deeper purpose to it all?
And that's where things get philosophical.
Yeah.
Remember the ultimate question of life, the universe and everything, from The Hitchhiker's Guide to the Galaxy?
Yeah.
The one with the answer of 42?
Yes. But I'm guessing Hawking and Mlodinow's answer is a bit more nuanced than a simple number?
Definitely.
Yeah.
They explore the implications of M theory and the anthropic principle, which suggests that we exist in a universe that allows for our existence.
So it's not that the universe was designed for us, but rather that we can only observe a universe compatible with our existence.
Exactly.
We're inherently biased observers.
Exactly.
Yeah.
And that's why certain fundamental constants in physics seem so perfectly fine-tuned for life as we know it.
Right.
If the strength of gravity or the speed of light were slightly different, stars wouldn't form, planets wouldn't exist, and we wouldn't be here to ponder these questions.
It's like winning the cosmic lottery.
Yeah.
Except the prize is our very existence.
Right.
But this raises a question.
Yeah.
If there are countless other universes out there, as M theory suggests, could there be universes where those constants are different?
Right.
Where life takes forms we can't even imagine?
That's a question that fascinates both physicists and philosophers.
Yeah.
And it's a question that Hawking and Mlodinow explore in the remaining chapters of The Grand Design.
I'm eager to delve into those remaining chapters.
Yeah.
So far, we've covered a lot of ground.
We have.
From ancient myths to the mind-bending idea of a self-creating universe.
Absolutely.
Where do we go from here?
Next, we'll venture into some even more mind-boggling territory.
Okay.
The concept of alternative histories.
Okay.
The nature of time and the possibility of time travel.
All right.
Get ready for a wild ride.
Okay, so we've journeyed from the origins of the universe to the mind-bending idea of multiple universes, and now we're venturing into the realm of alternative histories.
Yes. This is where my brain starts to feel like it's entering a science fiction movie.
It does sound like science fiction.
Yeah.
But Hawking and Mlodinow ground this concept in the principles of quantum physics.
Okay.
It's all about challenging our everyday understanding of time and causality.
So walk me through this. How does quantum physics lead to the idea of alternative histories?
It all starts with the idea that at the quantum level,
Okay.
the past isn't as fixed as we might think.
Right.
Instead of a particle following a single path from point A to point B, quantum mechanics suggests that it explores every possible path simultaneously.
So instead of a straight line, we need to picture a particle taking an infinite number of paths all at once.
Yeah.
That's a pretty wild concept.
It is. And it has profound implications for how we understand the past.
Okay.
It means that the past isn't a single fixed narrative,
Right.
but rather a superposition of all possible histories.
Okay. I'm trying to wrap my head around this.
Are we saying that every decision we've ever made, every event that's ever happened, has created a branching path in the universe's history?
Right.
And all those paths coexist in some strange quantum way?
That's a good way to think about it.
Okay.
It challenges our intuitive notion of time as a linear progression.
Right.
In this view, the past isn't set in stone. It's a collection of possibilities that all exist simultaneously.
So does this mean there's a version of me out there who made different choices?
Right.
Who lived a completely different life?
Yeah.
Is there a universe where I'm an astronaut instead of a podcast host?
It's a fascinating possibility.
Yeah.
The one that we can't directly observe or test.
Right.
But the idea of alternative histories forces us to reconsider our assumptions about the nature of reality and the role of observation in shaping that reality.
It's like those choose-your-own-adventure books, but on a cosmic scale.
Right.
It makes you wonder, what are the implications of this concept for our understanding of the grand design?
Well, it reinforces the idea that the universe isn't a static, predetermined entity.
Right.
But rather a dynamic and evolving system.
Okay.
It's constantly exploring all possible paths.
Yeah.
And the path we observe is just one of many potentialities.
So this grand design isn't a fixed blueprint,
Right.
but a set of rules that allow for this incredible range of possibilities, including the possibility of multiple histories.
Exactly.
Yeah.
And that's what makes the grand design so compelling.
Right.
It encourages us to embrace the uncertainty and vastness of the universe while acknowledging the power of scientific inquiry to guide our understanding.
This has been an incredible journey.
It has.
We've covered so much ground, from the human quest for understanding to the mind-bending implications of M theory and alternative histories.
We have.
It's a lot to process.
It is. But the beauty of it is that it opens up more questions than it answers.
That's very true.
It challenges us to keep exploring, to keep pushing the boundaries of what we know.
Yeah. As we wrap up this deep dive into the grand design, what are some key takeaways you hope listeners will carry with them?
I hope they'll remember the remarkable journey humanity has undertaken to comprehend the universe, from ancient myths to these elegant theories of modern physics.
Right.
We've come a long way.
Yeah.
But there's still so much more to discover.
And that journey of discovery is what makes it all so exciting.
Absolutely.
Yeah.
I also hope listeners will grasp the implications of a universe that might be self-contained and governed by laws that allow for spontaneous creation.
Right.
It challenges us to reconsider our place in the cosmos and to embrace a view of reality that is both humbling and awe-inspiring.
This entire conversation has definitely shifted my perspective.
It's been a pleasure.
What a fantastic deep dive into such a thought-provoking book.
It has been a pleasure exploring these ideas with you.
And a huge thanks to our listeners for joining us on this incredible journey. Until next time, keep those minds open and those questions flowing.